Yes, welcome to this is Madhava Madhireddy, and I am continuing our lectures for the Business Accounting 5931, and we are looking at our um, the in this lecture we will look at the cornerstones of good research. Last week we talked about literature review and what is scholarly article and stuff. Now we are looking at what constitutes a good research, and we'll talk primarily about two things. One is reliability and the other one is validity. Then we'll go deep into the classification of validity and so on. So it's going to be a good fun exercise for today. Now let's define what these two terms are: reliability and validity. So reliability is consistency. Let us say you want to check your weight. Now you have a weighing machine at your home, you stand on it and it says 57. Well, obviously you are a little bit disappointed that you are overeating, maybe you are disappointed. Now you want to check again, and then now you stand on it and immediately it shows 56. Okay, and now you just want to you stepped out again and then you stand on it again, now it shows 59. So now you have three different results, and in a span of like let's say 3 minutes. Obviously the scale is not very consistent. So consistent means it has to produce a reliable result with each performance. So validity, on the other hand, is talking about the accuracy of the scale. So let us say you stand on the scale and it says 120 kilograms. Obviously, you know that it is not correct. So you know you can validate externally. I mean, okay, let's talk about validation. You can validate that you are this is a there is a problem with the scale. It is not very accurate. You can say that. So that is the difference between a reliability and a validity. Validity can be actually termed as accuracy. Now we will go into a little bit deeply on how we can look at stuff that is reliable but not valid, and then valid but not reliable, and so on. Like, so we can check. We can go a little bit deep into these two terms. So reliability is easy to measure. It is a consistency of a measure. That means it is the ability of an instrument or anything, any measuring device, to accurately measure and access these two things: a constructs. So you need to have two different things. One of them is called a construct, and then the other one is called an operational definition. You need to have very clear definition of these two. The construct cannot be directly observed or measured, but the operational definitions, for example, they that is an explicit explanation, that is a very clear cut explanation of the variable, of how it is measured and manipulated. So that is the ability of an instrument to measure these two things. So you should be able to assess how clearly you are able to define a constant and how clearly you are able to look at operational definition. Now we'll look at these with a few examples in the coming slides. Now let's move on to the type of constructs. The constructs can be either a numerical measures or a non-numerical measure. A numerical construct is usually called a quantitative measure. A non-numerical measure is a qualitative measure. For example, a numerical measure could be a weight will be a numerical measure. A non-numerical measure would be the color of your eyes. That is a non-numerical measure. How many people are having blue color eyes? Like, what is the color of the eyes of a particular person? What is the ethnicity of a particular person? That could be a qualitative measure. The scales of measurement are very useful, because if you talk about identity, that means each number must be unique. The order in the means that they are ordered in sequence. That means if you have a Uber rating 5 star rating is better than 4 star rating, there is an order, and so on. We can also divide them into equal intervals. That means the distance between any two numbers on a scale is equal. Like for example, if you look at a clock, so the distance between any two small points, any 2 minutes uh, symbols, minutes markings is the same. So that is equal interval measurement. Then we have true zero or absolute zero. The score of zero on a scale is that is a fixed point, and we can measure everything based on that. Those are the fundamental scales of measurement. We need to have these things. We need to know and understand what an identity is. That means unique number, what you need to order the sequence, and then the intervals and the absolute 0 point. Now let's look at the scales of measurement. There are four scales that we are primarily going to use and primarily going to get familiar with. One of them is a nominal scale. A nominal scale is nothing but a category. So what is your favorite party? What is your favorite cricket team? What is your favorite color? Like anything that doesn't give, that you cannot give a number, that's we can give that into you can push that into a category sector. So what type of car you like, that could be a category as well. That would be based on the identity. And then ordinal is primarily a ranking. So what is your grade? You got A grade, B grade, C grade, F grade. So that is a ranking. Then we also have an order in that. Now the other one could be interval. Interval means how much you like certain item. Like let us say it's called like let us say you watched a football game and somebody asks you how much do you enjoy the football game. You can say I hated it. I really hated it, and I mean, I really hated it. I hated it. It is very boring. It's okay. Then you can say it's good. It is very good. It is super, right? Like this is like a Likert scale. This is called an interval scale, and we can also give unequal intervals, and then that could be a Likert scale would be an example of an interval measurement. The ratio is just a measurement of a quantity. Why do they call it a ratio instead of like a number or something? Because let us say somebody asks you what is your weight. Let's say you tell them like 52. So 52 kilograms means what? 52 is a number, is a ratio between your weight and the weight of a 1 kilogram. That's why it's called a ratio. So the ratio scale is any quantity, a high or height, like 1.8 meters means 1.8 times you are longer than a meter, right? You are, when compared to a meter scale, exact meter scale, you are about you are 1.8 times of that. So the types of measures, we are looking mostly at a questionnaire now. So in a questionnaire, it consists one or more constructs. First of them is a scale score. So in a scale, so we can do a sum or an average of the numbers presented to the items in a document. Like for example, um, like how many children do you have? So we can add the children, we can do the number of median children and stuff like that. Like we can do a scale score, and we can also do a response format. Like it can be open-ended versus close-ended responses. What do you think of this? And then it can be open-ended response, what do you think of the Scott Morrison government doing this? Then it can be an open-ended response. Or you can force a choice. You can say like you like it or you don't like it, you strongly disagree. So you can force a choice in the response format. So it is up to you to design the questionnaire. So the user will just follow what you want, how you want him to respond. You want him to give a numerical number, he will give a numerical number. You want him to give a scale, he will give you a scale. If you want him to give an open-ended response, you just want to collect an opinion, so he will give you an open-ended opinion. So depending on how you question, how you formulate your questionnaire, you can get the answers. So formulating a questionnaire, writing a questionnaire is a very skillful art, and it is also a science. So let's look at the difference between observational and unobtrusive measures. So observational measures are rated by observers, and without their knowledge you are performing the behavior. For example, I want to check how many of you are going to go to the gym every day. Okay, so how many of you go to the gym right after the class? So let's say if I want to do that, I can ask you that question, or I can also, maybe if I don't trust you, I can do an observation saying that how many of you are actually going, and then because if the gym is right next door, so you can actually go and take a look. Maybe you can put a video. So basically you I do not like you, the person who is being observed, he is not sure about the fact that he's being observed. Then the other one is an unobtrusive measure. So in the first case, the observer does the observed person does not know that he's being observed. In an unobtrusive measure, these are the behaviors or situations without without actually disturbing the natural behavior. That means we don't um, like we don't need to do anything that changes the natural behavior of the person. So that means unobtrusive means we not obtrude, like we say, oh, so wait here and we want to do this, wait here. So they let them do whatever they are doing naturally, and then we gather the information based on. And if there was awareness also, there is no problem in this case. Psychological measures are the measures of bodily temperatures and physical reactions. Your temperature, physiological measures could be temperature, your heart rate, your blood pressure. These are all physiological measures. And then like a pupil dilation, like for example, if you see something scared, how are your pupils dilated? So these are all physiological and biological measures. Now assessing the reliability is when you measure something, you need to assess whether that is reliable or not. So consistency of scores is very critical. That means when you are measuring the same item one time repeatedly, you need to know that the results are consistent. So, and between the, let us say you are the observer and somebody is doing the rating, so there has to be consistency between the different raters and observer scores as well. So otherwise we cannot do the we cannot say that our measuring, our measurement technique or measurement equipment, whatever that you are using to measure, is fully reliable. So we need to make sure that there is consistency on two different forms of scale, and also consistency on different kinds of people. Like for example, if raters are doing this, that should be um, uh, uh, different between different, if different people are doing it, they should also agree. For example, if someone is doing the measurement, you are getting 30, and another person is doing the measurement, you are getting 40, that means it is not very consistent, right? So the people should also, different people doing it should also yield the same result. And even one person do it, he does it repeated times, he should also get the same result. So that is the basically what reliability means. It talks about the consistency of or repeatability of the data. Now we have data analysis programs that we will learn a little bit. SPSS is one of the things that we will learn in this course, and it basically entering the data. All statistical programs have a specific format to follow while we're entering the data. Then we need to have scale scores. How do you need to recode it? Do you want to add a score to the total score? And these are all like computation of the final of the score cells. Then we need to compute the internal consistency, which is about using the same values as the total scale score. So the other one, reliability is done. Now we are moving on to validity. Validity can be uh, like a face validity is a measurement of something on the face value, and the construct validity is the extent to which the characteristics characteristics of the construct are mirrored. Means when you have certain characteristics of how you designed it, how much of this is clearly represented by the measure that you're doing. That means if it is clearly represented, then you can conclude that the validity of that particular measure that you employed is very good. Then we have content validity, where you include all the aspects of the construct by the items on a measure. So the content validity also is similar to um, is also a reliable tool when you are validating the whole content. And then we have convergent validity. That means we anticipate a relationship between the two scales that are measuring a similar construct. That means if your height in kilograms should be in a similar in similar relationship with your height in pounds, so that's called a convergent validity. And predictive validity is like a positive relationship between scores and a future behavior. So positive predict, that is about prediction. So you will have the predictive capability if you let us say you design on the x-axis, y-axis, you create a scatter plot. Predictive validity means it will give you, as the axis increasing, y is also increasing in that same along the same trend line. So the construct validity, let's delve deep into the construct validity. Let's look at the divergent validity. We'll look at the convergent validity. Now we'll look at the divergent validity. Divergent is the opposite of convergent validity, in that there is absolutely no relationship or there is a negative relationship between the two constructs. So in this case, a criteria validity will be a positive correlation between the scale scores and a behavioral measure. A concurrent validity, on the other hand, it's a positive correlation between the scale score and the current behavior that is related to the construct assessed by the scale. If you look at the predictive validity, it is a positive relationship between the scores and the behavior. So these are the elements of the divergent validity. So we looked at the convergent validity and also the divergent validity. Now let's move on to reliability and the validity at the basic study level. The reliability of it, if you want to if you want to truly say that our study is reliable, then we need to see how consistent the study results are across similar studies. That means your results should be in agreement to a little bit, at least to a little bit. They must be in agreement with somebody else's doing a similar study. That is called lateral replication. So in a lateral replication, you conduct the same study with new people, right? You did the study with a few people, and somebody else can do the same study with different people. Then it should give the same result. For example, you want to calculate the acceleration due to gravity, right? It's universal. You calculated it and you got 9.8132 meters per second square, and somebody else does that. They should also get the same result, similar result. Uh, and then the conceptual replication means conducting the study, examining the same patterns or relationships, but we can employ a different measuring technique. We can use, for example, if you use the analogy, we can use g, the calculation of acceleration due to gravity, in another way, for example. So the validity at the study level can be internal validity. It is a degree to which the accurate relationship between the variables, if we change one variable, how is the other variable changing? So by establishing internal validity, you are saying if x is increasing, y is increasing. If x is decreasing, y is increasing. Whatever is the relationship, we can say that there is a very accurate relationship between two or more variables that we are employing for our study. The external validity is when we are using different procedures other than the internal data that we have, and in different settings, we're changing the settings in which we produce a result, and then we assess for different procedures also then we can say the data is externally validated. That means you don't use your own data to validate your thing, but you use external data, external procedures, external settings. That means your external validity means, that means it is externally valid. And always there is a debate between how much of internal validity should be there and how much of external validity would be there. But one thing is for sure, if you want to do if you want to do strong internal validity, you need to sacrifice the external validity scope, because you want, when it's like tuning everything to internally validate, then it becomes hard for external things to validate it. If you keep it a little bit more general internally, then it becomes easy for external validation. It's always a trade-off between whether you want the data to be validated internally or externally. You cannot get the best of both worlds usually, so you just need to like pick one and focus on that bit. I mean, you need to do both, but you just need one. if you if you focus on one, it is possible that the other one will go down and so on. Then the other thing that we talk about is consistency and accuracy. So consistency is similar to reliability, and accuracy is synonymous to validity, as we have just talked about in the very first slide. So the measurement reliability suggests that all the participants, they behave in a consistent way. A reliable measure means it is also a consistent measure. It does not mean it's valid though. We need to take steps to determine validity separately and consider what type of validity are we assessing. Are we assessing internal validity or are we assessing external validity? You need to make sure and take the steps to do that. So I hope you guys have clear understanding about what validity is, what internal validity is, what external validity is, and what is reliability is, and how to what is the what and how, and if you conduct a study, what is the meaning of a reliable study, what is the meaning of a valid study. So I hope you guys had fun, and any questions, guys?